Welcome everyone who have joined this session offline as well as those who have joined online. I'm Om Jadhav from Center for Development of Advanced Computing, India. I'm here mainly to talk about our experiences with Apptainer. Okay, so let me start. Okay, so this is just a brief agenda of my talk, where I will be mainly focusing on what kind of experiments we did with Apptainer and like what was our learning, right? With different case studies, with some benchmark codes, as well as some real life scientific applications from different domains, right? So let's start. So before proceeding further to the case study, let me introduce where from we are and what exactly we do. Okay, so we are from Center for Development of Advanced Computing, which is a premier R&D organization of the Government of India, which has been established to cater the computational needs of the Indian perspectives. Okay, so we are the organization who are actually responsible for different SPS facilities to be deployed across the country, as well as providing the support to the user community. We have a user community, more than 20,000 plus users, which actually deploy, which actually uses our deployed systems, right? And from the establishments to as of now, India has been running many mission mode programs. So the very recent one program is the National Supercomputing Mission, under which we have deployed various systems across the country with different supercomputing capacities, right? And the main motto of these systems was to proliferate the HPC technologies across the country with the different regions and to reach out as many researchers as possible. Okay, and this was actually four pillars of this mission. First, to create the infrastructure across the country, then foster the R&D aspects in the technologies, okay, and then creating or developing the national needs applications, and parallelly training the manpowers who can use these systems to proliferate their research fields. Okay, so this is just a brief about us and what exactly we do. So coming to the point, right, as I had mentioned, we are the people who actually provide the systems to the users and maintain the software stack across the system, from the initial deployments to providing the supports, helping the users to port their applications, to parallelize their codes, optimize their codes, right? So in this journey, we across multiple challenges, right, to specifically with respect to HPC application deployments, right, like portability. So taking one application from one system to another system, right? So certainly there are some challenges involved with respect to dependency, as well as when one system gets ready, right, for the users. So before giving that system to the user, certainly compiling and making that application, it takes some time. So ultimately there is a deployment delays, and sometimes if one application is performing X amount of giving X performance on one system, but on the similar kind of machine may not be giving that performance because of the version mismatch of the dependencies or the particular optimal setup of that system on the system. So in order to tackle these challenges, we started to explore the different ways of deploying the applications optimally, right? So along with this pack, we were trying to explore the container technologies as well. So we just did some literature survey. Then we certainly find out, yeah, these can be the good options with respect to containers, because those are lightweight, fast to deploy, right? And they can like certainly be the candidate which can help out to cater some of the challenges with respect to application deployments and maintaining the stacks and those. So in that direction, actually, we started and we got eager to use these technologies, right? So then we tried to do some literature surveys and explored some of the available like container technologies, okay? And then we focused on Apptainer because through the literature, it seems like it's good for HPC kind of the environment, specifically the environment where multiple users are using the systems and they want their standalone setup, and that too with that application or their code giving optimal performance, right? So our users are actually ranging from the different scientific domains, starting from the weather, biomolecular domains, molecular dynamics, CFD, and so many. So our main target or motto is to make those applications optimally on those every system, so that users can optimally use that system, right? So in that direction, we
Recording in progress.
We explored this Apptainer to demonstrate our users, so how it can be an option, alternative option for you, so that you can start using it, and we make that available on our cluster, right? So this is just a slide where I will not explain it, okay? So as everyone here, everyone knows about what exactly the Apptainer, so I will not spend time on that, okay? Straight away I will go to our experiences with Apptainer and what exactly we did. Basically, before providing this technology to the users on our system, first we need to validate, and we from our side should be confident that, okay, yeah, this tool or this utility works absolutely
Recording
fine.
in progress.
So in order, by keeping that motto in mind, we explored this in a different aspects, right? So in this talk, I will be talking about some of our experiments with a single node as well as multiple nodes, with sample codes as well as some real life application, that too on the CPU as well as the GPU, okay? And so let's start. So we did our experiments with this version, okay? So before starting using the Apptainer, okay, so on any system, so first, what kind of prerequisites you need to do? So what we with our learning, we got to understood that, okay, these are some of the prerequisites certainly we have before using the Apptainer on that particular host system, right? So there are like system prerequisites as well as software dependencies and user level consideration, because on a shared kind of the system, there are multiple users and they work into their home environment itself, right? So we want something which can work in that scenario, right? So then once these prerequisites are there on the system, you set up it onto your environment, right? So there is very like step-by-step information is provided how to set up it, okay, on this particular slide. So once you've installed it, right, so like how easily or how optimally you can run the Apptainer with your environment, right? So if consider that, okay, this one is okay, this one, let's say, is a command for the bare metal run, okay? So adding some of the Apptainer related commands, okay, and binding your host MPI, you can make that Apptainer running on your system, okay? So in the form of the ease of use, okay, in this way the Apptainer can be certainly used, right? So now consider that, okay, now you have the setup. So from the start, let's say you have set up the Apptainer on your host system. Now I just want to get use of it, right? So let's say if you're only a user, okay, so you can just take a Apptainer image from the verified resource, either from the repository or from the the build image which has been securely built by some of the admin of that particular user. You just directly take that image and start running on the system. So that's as easy as, right? And another way like that, you want your own image to be built, right? So certainly you can create your image, either you are admin as well as from the user admin app as well, right? So as like admin like us, we generally try to build the as much image as possible for that particular scenario or for those users and make it available. That is also the scenario. Or if you are a user, you can just create your own file like image, okay, just build it, okay. This just a snippet of definition file where you everything mention, okay. You once you create the definition file, you just build it, okay, then test on that particular system, and yes, you are ready, and you can just run that on your system. So this is actually, this can be actually the workflow from the user perspective, right? So here I'm mostly talking about looking at the Apptainer from the user perspective. If I want to use the Apptainer, what can be the best case scenario, right? So this is the way. Now, once this whole workflow and everything is ready on the system, now let's talk about some of our explorations, okay? So first we tried to explore on the benchmark kind of the things, where we took one sample matrix multiplication code, okay, and with that we did some of the explorations, right? And that too on the single node of the machine. So this is one aspect or one kind of results where you can see that we have created image on system 1, okay, and we try to take the benchmark how actually it performs. Now, and then we created the Apptainer image, and we try to take, so you can see that, okay, on system 1, which was actually a kind of for some teraflop system, and then we try to build the Apptainer and just try to check the bare metal performance as well as the Apptainer performance, and you can see the performance difference. So now then what we did, that we take the same image to another cluster of a similar architecture, okay, and we just try to run that, okay, on that particular system, system 2, okay, and then there as well, like we try to check the performance. So what we found here is that, okay, so at initial building level, certainly there are some challenges involved, okay, initial challenge, but once you have working image with you, okay, so deploying it to another system, it's it takes very minimal maneuver efforts, right? And you can start directly using it, that to having the minimal overhead, right? And another aspects, when we try to check the scalability aspects, here our objective was to check whether by increasing the number of cores as on the bare metal system, how if we run the same code with the Apptainer, whether it tries to follow the trend, scalability trends. So in order to check whether with the different workloads, does it provides any overhead on the systems or not. So here we observe that yes, it follows the trend by increasing when we increase the number of nodes, and especially it follows the trend with respect to the bare metal system, right? So this was one aspect. Then another aspect, we try to explore that environment reproducibility. So as I was mentioning, we build the system image on one platform, okay, and then we try to take that image to different systems, like system 1, this IIT Bombay system, system 2, IUSC system, as I was mentioning earlier. So we are the people who have deployed various systems across the country, and various users uses it. So we took that same image and we wanted to check whether it works on a different platforms or not. So here main objective was to check how much, from the deployment perspective, how much man hours, efforts, how we can reduce. So once you on the first system build the image on one system, and then deploying that image and that whole ecosystem from the user's perspective, it becomes very easy, right? So for the user, it ultimately they want their application to be run. they don't want care whether I am running it via the Apptainer or any other bare metal kind of system. So if we could make that easily available, then that work is done, right? So we try to check its workability across the different systems, starting from the architecture family, as well, changing the systems with having the software difference as well as the hardware difference as well, right? And what we found that Apptainer actually works across the different system, and the one good thing is that it reduces the deployment time drastically, right? Maneuver efforts as well. Then another aspects we try to explore is that testing OpenMP and MPI aspects, just wanted to check if we go for change multi-threading or multi-processing. Okay, so the Apptainer, which is certainly any container create some kind of overhead maybe as compared to the bare metal systems, but how robust it can be when it comes to a real life application. So certainly every applications, they are implemented in a hybrid mode. So we just wanted to check when we change the number of process with respect to the number of cores, how actually the Apptainer behaves, right? So in that scenario, by keeping constant number of cores, that's 48 cores, right? We just try to check, change the number of threads as well as number of process, and though we get a native execution or the bare metal execution, right? So how actually we get the performance with respect to Apptainer as well. So here as well, we one thing, good thing observe that Apptainer works in that scenario as well. So with respect to the multi-threading, as case with the bare metal, with Apptainer's configuration as well, the things run. So from the user perspective, this is one also a good signal that yes, we can explore. Now, and after that, so this was like a bit case study with respect to different aspects of checking the single node, okay? Along with that, we checked multiple aspects, other aspects there as well, but due to time constraint, I just added some of them. Then we switch to real life use cases, okay, for the multi-node scenarios, right? So how actually the Apptainer behaves exactly when we try to use, user may try to use the real life application. So here I'm going to demonstrate you the use cases with respect to two scientific domain use cases. One is from the material science domain, the quantum espresso application. Many users uses it. We have the large user base for that application. Another use case I had taken for the NAMD application, which is from the molecular dynamics domain. And we just try to simulate these aspects. So the quantum espresso version 7.3.2, so first with the CPU version, okay? And here, this simulation was regarding the copper oxide crystal, and we were just by relaxing that. So that kind of simulation we did with the quantum espresso. And then another application was like a NAMD application, where we run the dynamic simulation of STMV, like that's a small virus, and how actually it behaves in given solvents like water, right? So this was just a bit about that simulation, and we try to run this workload on the bare metal system, and we just trying to compare the performance, right? So with this, so the quantum espresso application as well as the NAMD application, you can see that, okay, two aspects here, two main observation, whether it gives a near native bare metal performance or not, that is one aspect. And another case that when we try to increase the number of nodes, as we increase the number of nodes, MPI, fabrics, networks, many things comes into the play, right? So whether it follows, so yes, certainly it follows the thing. One important thing that with respect to quantum espresso application, one observation was that when we try to go for the higher number of nodes, there may be little overhead because of the IO nature of that particular application, but it gives the acceptable kind of scenario where the user, if not the very time critical scenario, one can go with the Apptainer. because of the its use and ease of deployment and those aspects. So these were some of the things with respect to the results and observations with respect to the multi-node scenario of application. Then with respect to GPU use case, okay, we choose the NAMD GPU version, okay, and the same input, and then we try to run it on the single card and two cards, okay, on the same node, and we try to compare the bare metal performance with respect to the Apptainer performance, and certainly in this scenario as well, yeah, it is good, okay. So what we observed in general with respect to the CPU applications as well as the GPU applications, okay, if we just overlook little overhead with respect to minimum overhead with respect to performance, but Apptainer can be the good choice for deploying the applications not only on the smaller scale but also on larger scales, because its use of maintainability, use of ease of use. So those are aspects, certainly those are positive aspects, but certainly there are some initial challenges which I was mentioning, okay. That initial perspectives or initial challenge with respect to environment setup, binding of your image, so those are theirs. If we just cater those things, certainly it can be a good option for you to deploy the applications on the systems. So keynotes for these explorations are certainly we can go for it because it doesn't require a root escalation. So from the user perspective, especially on the shared kind of the scenario, that can be a good option, okay. And but still, though you use it, there are some generic recommendations, okay. We need to certainly look or give for the user perspective that use always trusted images, right, because those are immutable. It should not harm your user space, and those aspects are there, right. And certainly you can limit the bound. So this is also one of the very good feature, actually, I personally feel with respect to the Apptainer, that you can gives or show the required directories as well, required directories only to that particular image for the user, right? So that your data security and those certain concerns can be overtaken by the Apptainer, right? So just to conclude the things, as I was mentioning, yes, Apptainer can simplify your work with respect to the deployment and maintaining the things just with very little minimum overhead, and certainly it's scalable with respect to the bare metal systems. And if you just can work around with the initial challenges with respect to certainly deployment on your host or those systems, so that can be a good candidate for you, right? And especially the scenario where we work on the HPC kind of the environments, and when you are dealing with large amount of the HPC users, okay, with having their lots of queries, certainly this can be the good option. So I think that's it from my side, okay. Certainly lastly, I would like to acknowledge my team and our centers who have given the opportunity to present our work here. And also I would like to my team members as well from the HPC Technology Group, C-DAC Pune, where they support the users across the country and maintain the user community from their end. Okay, so thank you very much. If anyone have any questions, I will be open. Yes. Yeah.
Hello, yeah, thank you for this talk. It's very interesting. You have done some very exhaustive study. Yeah, my name is Akash. I work at Argonne National Lab. One thing that I've observed, I worked with Singularity in the past, and at that time I was trying to build Singularity containers from Docker images. And one of the challenges that I faced, that if I'm on an HPC system, I sort of have to rebuild the image every time using the host MPI. And in your results, you showed that you didn't have to do that. So was it just because you were purely using purely using Apptainer images as the direct source of truth, versus not using Docker? What was
A very nice question. Really, so what I observed with respect to Docker versus the Singularity, the very basic difference. Apptainer offers you to bind the host like MPI. So you don't need to once again rebuild the Apptainer image on the host system. So as I was showing in the very first slide, one slide, just let me go back, okay? Yeah, this one, yeah. So here you can see that this export MPI directory, that is the host MPI, right? And here you just need to bind that, and that it will create the plate for you. So that's actually one of the important feature which I feel personally that makes this Apptainer very easy for HPC users like us, right?
So if there are lesser differences in the system,
Yeah.
And then you are binding your host MPI
Yeah.
to an image MPI that is built on a different system.
Yeah, yeah.
Then do you see any because your systems are pretty similar.
Yes. One thing that maybe this slide, yeah. Here I have just kept one statement here. Okay, you may have been observed. Okay, so if let's say Apptainer is there and which has been built for one version of the either MPI or the CUDA, let's say whatever. So if that version is compatible with the hardware, so you just need, like as I was mentioning, some prerequisites there. Only prerequisites you need to have that the compatibility of the versions of the, especially the MPI compilers or the CUDA compilers with respect to host system. So here itself, so the benchmark which I had taken, right? So the Apptainer image which I had built was built with CUDA 11.2. But when I was running on the host and I had taken this benchmark, the host CUDA version was like a 12.8 something, right? So you just check the compatibility of the similar version. If you are using the Apptainer Intel MPI, you just make sure that on the host Intel MPI is there, and most of the things will be done for you. Yeah, thank you.
Okay. So one more question.
Hi, I'm Alex from AMD. I was wondering about these numbers you have up here. Are these averages of runs?
Yeah. Generally we the average of 5 runs and then the average. Yeah.
And what do you attribute the small difference
to? Yeah, certainly that's a good question. So two things, like we are also trying to explore one aspect. As I had mentioned, some of the experiments I couldn't show it because of the time experiment. So one experiment was regarding how I can check the Apptainer container overhead, right? So when we try to bind the image from the host, certainly it's for that binding, it takes some like time. That is one aspect. Also another aspect, that when you go for like a larger number of nodes, another like aspects with respect to network, memory interface, taking the data, writing back, so those kind of things certainly creates little but very negligible overhead. So whatever the attributes, like very minimal difference, that is one aspect. And another, that like when we go for system to system, so node health and those aspects also plays the thing. So these two things can be the scenarios which the smaller difference may have been created. Yeah.
All right, so I'm the next talk, so let's move on to that. I also want to make a comment that maybe you haven't tested this yet, that a lot of system administrators have found an improvement in performance by when you run your large scientific applications that have tons of files, and you put them in one CIF file as opposed to unpacked when you're bare metal. You have to have them on your shared file system like Lustre, and you start up a whole bunch of nodes at once. They're all competing with the metadata server. Whereas you have the CIF file and it's mounted on each node, then you have much less metadata server operation. So that's something you can actually show an improvement.
Yeah. Thank you.